Hi, today I'll be talking about the 5 key components to creating successful and engaging online earth science labs. Just a little bit about me. If you're here on my YouTube channel, you know a little bit about me. I create videos to help people understand earth processes. The screen here you have on the left is how I see myself. I see myself as a geoscientist taking students out into the field to learn really complex things on their own. In reality, I'm an online instructor. I teach introductory earth science courses. I've been doing so for a long time, and I use a lot of different technologies to help my students learn, including lecture videos like you have here on the left. This is a seafloor spreading tutorial that I created that many students have benefited from, not just my own students. But all in all, when it comes down to it, I have over 15 years of teaching experience, and the majority of those years have been creating and facilitating high quality online engaging courses. And in that time, I have determined what it takes to make a really good online lab course. It really comes down to 5 major key components, which are the design of the course, making sure the courses are tactile, making sure that they're relevant to our students, thinking about how we use instruction in the online format, and the feedback that we use. So today I'll be talking quickly about each of those topics. When we talk about lab design, I think the first thing that faculty come to me, and I've worked with a lot of faculty to help them learn how to create good online classes, and also to talk about what would work well in their classes. But most of the time, faculty come to me and they say, how do I take my course and put it online? They want to take every single lab activity and assignment and they want to put it into the online format. And the reality is that the labs and the courses themselves, they don't have to be exactly the same. And in fact, it's really better to go at course design from a fresh page. We need to step back for a minute. Think about what the students need to learn, why we're doing certain things in our face-to-face classrooms, and how we might do those same things in the online format. Basically, what we do is we work on a scaffolded design. So we start with our course competencies or outcomes. So what are the goals of the course? And then we have to decide, do the students need to do exactly what they were doing in the face-to-face classroom, or is there perhaps an alternative way that students can do it in the online format, but still meet these course competencies? So basically, we're going to go in a backward design process, starting with what the students have to do, and then we're going to work backwards and try to identify all the steps to get them to meet those competencies. Now, lab goals tend to be around 2 different things when we talk about the earth sciences. We might have skills that they need to demonstrate, perhaps like map reading, or maybe the lab is just to go over specific types of content. So in an introductory geology course, we talk a lot about mineral properties. So the lab that's tied into the minerals unit is just going through and practicing using those different properties to identify minerals. So this is more about content reflection versus a skill demonstration. So once we know what the students need to do and how we might do it online, then we start working through it. So some examples. When we talk about labs, I'm going to just show this as an example from one of my classes. I've used this Flubber Glacier lab in the face-to-face classroom. This was designed by Lee Stearns at, I believe, Kansas University. So basically, this is a big model. It's made with PVC pipes. We use Flubber, and the students get to manipulate this model to figure out which parameters change the speed of the glacier moving. So they change the slope, they change the temperature of the glacier, and they change the texture of the valley. So if you want to know more about that original lab, you can check it out here. So now the question is, how do we translate this into the online lab environment? So one thing that I did is I actually just used the same model, but instead of having my online students use that same model that we have in the face-to-face classroom, they now use plates and they're making measurements and they're doing all the same calculations. So it's very similar. It just doesn't have that physical manipulation of the model. The goal for my students was to actually get practice doing the calculations, and they're also making measurements and learning about those 3 parameters that are affecting the glacier's motion. So they're still doing it in this way. It's just a little bit different because we're not using that physical model. Now, if playing with the parameters is more important, an alternative option would be to use a simulation. So this is a simulation coming from PhET, which are set up through the University of Colorado at Boulder. And so you can use these shortened URLs to get to this lab, but basically this is a digital model. The students can change the different parameters and they can make the glacier advance and retreat and still talk about those different processes. So again, an example of how we can modify the face-to-face activity into 2 potential lab activities for the online format. Another example is just thinking about this is an example for an optical mineralogy class. So if you want your students to go through and do things, maybe you do need them to use a microscope. So you might have to think about the materials that are provided to your online students. There are certainly companies that you can work with to provide students access to microscopes. You might have them go through and just learn about some of the things. Maybe some of the labs are done online and some of them, maybe the class is hybrid and they come in for the course. It doesn't mean they can't do some of the material, go through some of the content and the activities in the online format. So the examples here, we have a mineral optics. This is like a learning object that students can go through and learn about the differences between polarized light and what they're seeing in the minerals. So you could assign this as something that they would do perhaps before coming into class, or maybe this is enough to get through some of the key competencies for the mineralogy class. Another example is actually just looking at an online lab option. So this is through Open Science Laboratory, and here you can see we have a thin section, an image, and then the students are identifying, the different minerals in this virtual lab. So this is another option. They don't actually aren't actually using the microscope, but they're getting practice and understanding the different properties. So when they're in the classroom and they're using the microscopes, they've already gone through a lot of the content, and then you can help them with the more specific identifications. Tactile experiences are very important in the online classroom. We often think that they can't be done, but in reality, there's no reason why they can't be included. So tactile experiences include a wide range of things. One of the first things that comes to mind is a skill demonstration. Now, I've worked at a technical college and we have, nursing programs and we have all kinds of things. So I have some examples here of like hand washing skill demonstration. So how to properly wash your hands, how to do a dissection. So using something around the house to show the different, if it's a lengthwise cross section, longitudinal versus a cross section through the middle. So you can actually use other objects to get back at some of those basic skills before they're maybe actually doing a dissection. Now here we're talking about geoscience, so maybe making measurements is more important. So for my geoscience courses, I think of map reading kind of falls into a skill demonstration. Perhaps if you want to see the students doing a streak test to do a mineral identification, what we can have students do, they can still physically do these things. We just need to find a way for them to record what they're doing, share it with the instructor, and then have the instructor give them feedback. So we need to provide detail. They can write down a detailed explanation. A student can tell me how they're going to be doing a mineral identification. They can document it using photos or videos. So we can use tools, free tools online like screencast-matic.com, a screencasting tool, or something built into a smart device. They can record what they're doing, they can upload it in the course, and you can determine if they've correctly demonstrated that skill, possibly through these 3 options. Tactile experiences include many things. I'd say in the online environment, simulations are a really wonderful tactile experience that you can include. I have a couple of examples. So one I've used in a historical geology class is set up through the Howard Hughes Medical Institute, these biointeractives. So these are online learning activities that can be incorporated. So in this case, the students are learning about microfossils and sediment cores, and then they're going through and they are looking for the changes, making measurements, determining what's going on to figure out when the mass extinction happened in the ocean. And this was related to the end, the extinction with the dinosaurs. So PhET, again, already mentioned before, has lots of simulations. The one that we're looking at here is something I've used in an oceanography class to help students understand wave interference and what happens, why waves start to refract, what's going on when you have waves entering an enclosed bay, and so on. So they can manipulate it. While it is still on the computer, because they can change the parameters, it makes it a tactile experience. If you want more example of simulations, I definitely recommend checking out the resources through Merlot, and you can use this shortened URL to get there. Now, a new tactile experience that I've started including is the use of 3D models. Now, when I say models, a lot of you are thinking about 3D printers and being able to print all of these things. And if you have the options to maybe have things printed, put into some sort of kit that are then distributed to your online students, that is fantastic. Alternatively, 3D models, when you go in, you start to look at tools like Sketchfab and Thingiverse, the models themselves have these 3D rotations. So a student you can send a link, and maybe you want students to look at, this is a benthic foraminifera. So maybe you want them to take a look at this foram, and just so that they can get an understanding of what it looks like, so you can see all the chambers on it. You can assign this to that student, and they can get in and manipulate the model without even actually having to have it printed for them. Additionally, the one we have here from Sketchfab, this is showing, maybe you're trying to look at mineral structures. So mineral crystals, maybe this is your fluorite that we're taking a look at with this octahedron. So again, to help students really understand those three-dimensional shapes, these models, these digital models, can allow the students through that manipulation to see it and better understand it. Next, tactile experiences also include applications. So a big classic one for all of us earth science faculty is to look at Google Earth. So we have some examples here. This is a lab I've used to use Google Earth to explore plate tectonics, and you can take a look. So Google Earth has many that you can look at, and CERC certainly has a large compilation of labs that are ready to go for your online classroom. All right. Tactile experiences, I think the number one we think about with our lab courses are our lab kits. So here is a lab from my own course about investigating minerals, and I've created a lab kit, which you can see here in this top image, and the students go through and they have minerals, they have rocks and fossils that they complete throughout our course. Lab kits can be a variety of things. There's many options out there. Whether you create something yourself or you find a pre-existing one, the students do generally appreciate getting to hold the different mineral samples and take a look at it. And if this is one really easy way to make your online experience more similar to your face-to-face classroom. All right. Now next, the third component that we really want to think about with our classes is making them relevant. It can be harder to do that, and it's super important when the course is online. So the students often need to see that connection so that it feels like something they want to do. So relevancy can come through the activities that we have them create. Anytime we're working with the students and having them direct their own projects or their own research can be a way to make it more relevant. They become invested when they have a say in what they're learning about or what they're studying. So an example that I have here for an earth science course might be for a sedimentology class. And in this case, you can assign them a sampling and sieving project. So you can take a look, check out this one from Woods Hole, but the students go out and maybe they're creating a project. So maybe it's something as silly as looking at which cat size litter particle size works the best for the cat. Or if you have a garden, what soil grain sizes work the best? Why is it that my garden doesn't perform as well as my neighbor's? That could be something where the students go out, they're going to collect samples. Maybe they have a set of sieves that's part of their lab materials that they can use. They can learn about the sieving process. They're going to create some sort of project report, and then they'll present that to you within your classroom. Because they had a say in what their original project was, they're going to feel more invested in the course and the content. Other ways we can make our courses relevant are just by trying to help connect them to things that they've seen. So an example that I have here is from my earth science course. In these, the students are using Google Earth to do their explorations. Our very first lab that the students do, they go and they make measurements around our campus building. So most of them live in the area or know of the area. So they're making measurements, actually just making basic observations, but for a place that they know. Then we start to go to places that are more similar or more nearby. So this is looking at differences in our stream channels, in and around the area. And then we can go even farther by taking it to places that maybe they've seen themselves or perhaps in a Hollywood film. So this shows Monument Valley. Every time I start talking about this, I try to connect back maybe to some Hollywood scenes that maybe students have seen. So maybe some Indiana Jones, where young Indiana is going through the Monument Valley area. So that sort of connection can help make the course more relevant for the students. Then we can also, in kind of the last drive to keep the courses relevant, try to connect your lab activities as much to all of the other learning activities within your unit. The example I have here is from my geology course. So the students do their identification lab. In this case, it's metamorphic rocks. And then that same week, we go through and we have a discussion where the students have to do some directed research related to metamorphic rocks of their choosing. So they have that choice, they get to make decisions. They're going to do some research on a metamorphic rock that they know about, and I give them some options, but the door is open, they can pick other things. Many of the students pick things that they've seen. So the example here is looking at the Baraboo quartzite around Devil's Lake in Wisconsin. So many of the students have seen this, but to really drive back making it relevant and connecting back to the lab, the students actually have to identify the sample in the lab kit that's most similar to the rock that they did their research on. And that just helps make that connection so that, in case that they had maybe forgotten what was in the lab, they're having to go back and look at it again and say, oh yeah, that is the quartzite. That makes sense. That connection helps make the course relevant. Okay, now we're into some of the last important things. So the type of instruction that we provide to our students is critical in lab courses, but even more critical in our online classes because we're not standing there with them, holding their hands to help guide them through the activities. When we create detailed instructions, they need to be very consistent in both the way we explain things and the general format. We need to always have detailed text explanations. The inclusion of video tutorials and images can really help guide the students because they will get to a point where they don't quite understand what you're asking them to do, but that video tutorial where you've gone through and explained everything makes a huge difference. You need to clearly identify any and all lab materials that are needed, and then provide time estimates and potential breaks for students working on their lab assignments. Most labs are 2 hours long. That's how they're assigned in a face-to-face environment. In an online environment, if a student gets stuck, knowing that they can take a pause, ask some questions to you, and then go back is really important. So telling them approximately how much time it would take. And if maybe there are different sections, maybe you encourage them to work on a section. If they have problems, come and talk to you, maybe in an office hours. These are ways that you can help them be more successful in their online labs. We also need to provide very detailed instruction related to potential hazards. So if you have mineral samples that maybe you don't want them to do taste tests on, make sure you let them know that. Many students taking our online classes have family members around when they're completing their assignments. They also have pets. So you might want to point out whether or not an activity is kid-friendly, family-friendly, or pet-friendly. If they have problems, you might say, hey, this is best a lab to do on your own. Or you might actually encourage them to incorporate their family in their activities because it then makes the course feel more welcome to their specific situation. Again, use text, video, and images to identify any potential hazards, and make sure you let them know what to do should they encounter any problems. Right. The last thing on here for the 5 components is having useful feedback. So when I talk about useful, lab activities are generally designed so that students can learn from their mistakes and correct errors in their understanding. To make sure that the online students are able to do that, we need to provide very timely feedback so that they can have time to make those corrections in their errors. So instantaneous feedback is probably the best, but it's also generally not likely if you're giving one-on-one feedback on every lab activity. So if it's going to be delayed, try to get it back as quickly as possible, but let students know when it will be returned, and even create activities that have the students go back and review their mistakes and reflect on it. That reflection period will allow them to make those positive changes in their understanding, make those corrections. You also need to make sure that you're very clear with how you're going to evaluate their work. So the use of rubrics, what you've put into your syllabus, and even the lab instructions will play a role in how the students know. I point this out because students in the online environment will be very afraid to get something wrong. But if your lab is truly a learning activity, then you'll want to make sure that you're evaluating them so that you're not penalizing the students for making mistakes. This actually will reduce any problems you might be thinking about related to cheating and plagiarism. If the students are allowed to make mistakes and then they're encouraged to go back and correct their misunderstandings, then maybe they do it, they get it, they get to move ahead. Or if they don't get it all correct, they have to review it before they can move ahead. All of these explanations, as long as they're clear for the students what the purpose of the activity is and how they'll be evaluated, you will see an increase in the student engagement and the successfulness of your labs. Okay, so I just went through 5 very important factors. There are many other important things related to online course development and online lab development. This includes accessibility, how we scaffold other course activities into the assignments, the types of interactions our students have. There are 3 major types that all students need to have within a course. So how they interact with content, each other, and the instructor, how you build your community of learners, what your role will be in your online classroom and how you'll be present for your students, and the importance of doing course reviews and gathering student feedback. These factors are incredibly important. I would love to talk about them another time, but for now, we've gone through the major 5, and I hope you have found this useful in the redesign or the design of your own online geoscience courses. So if you have any reflections, feel free to add those into the comments. Thank you so much for listening. I wish you luck in your course development and a happy journey along the way.